A small thing you take our water treatment plant or water reservoir, and I feel proud that they're very bright and they're all doing very well in their own fields.
If I were to describe SVCE in
சார் ஸ்டார்ட் பண்ணலாமா? சரி, சொல்லுங்க. இல்லை பண்ணல சொல்லுங்க சார்.
Hello, Professor Gopinath. Hello.
Sir, he is currently facing some power failure problem in his home place. He will shortly join with us within a few minutes' time.
Okay, no problem. Good morning, everyone. I think Sendil Rajan.
Sir, shall we start our session?
Yeah. We'll ask. Okay, you can start.
Okay, sir. Thank you, sir. Thank you. Very good morning, everyone present here. On behalf of Internal Quality Assurance Cell of Sri Venkateswara College of Engineering, I myself, S. Sendil Rajan, extend to you a very warm and hearty welcome to each one of you all here. It is a beautiful morning. Well, firstmost, I would like to thank you all for taking the time out from your heavy schedule and attending this webinar. Thank you so much for attending this event. Yes, my dear participants, we all know why we have been gathered here for. Of course, we have a very special event waiting for us. And let us start the webinar on cloud computing for everyone. I now request Dr. S. Gopinath, Professor, Department of Mechanical Engineering, and our Nodal Coordinator of IQAC, to deliver the welcome address.
Thank you, Mr. Sendil Rajan. Good morning, one and all present here for the international webinar on cloud computing for everyone. On behalf of Internal Quality Assurance Cell, Sri Venkateswara College of Engineering, Sri Permandur, I sincerely welcome all the participants from Sri Venkateswara College of Engineering and other institutions across India and abroad. I especially welcome today's guest speaker and my close friend, Mr. Kandasamy Umapati, Senior Director, HCM Cloud Operations, Oracle US Incorporation, Redwood Shores, California. Welcome, Mr. Kandasamy Umapati. Once again, I welcome all of you to this international webinar. Thank you.
Thank you very much, sir, for your warm welcome address. Now I'd like to introduce the today's presenter, Mr. Kandasamy Umabadi, Senior Director, Human Capital Management, HCM, Cloud Operation, Oracle USA Incorporation, Redwood Shores from California. Mr. Kandasamy has a bachelor's degree in Electronics and Communication Engineering from Madras University and a master's degree in Computer Science and Engineering from Bharatiyar University. He is also a certified project and program management professional from University of California. Coming to his professional experience, he is a software engineering technologist who currently heads human capital management, HCM, cloud development operation at Oracle USA Incorporation. He is currently responsible for hosting and managing HCM products in Oracle private, public, hybrid, and cloud models. He is also responsible for cloud data quality, data integration, and data diagnostics. He had a brief tenure at Tech Mahindra, where he developed and implemented software for telecom, billing, and business intelligence for British Telecom. He also taught several electronics and computer science courses at various colleges under Madras and Bangalore University. To know about the fascinating concepts of cloud computing and also to understand various job prospects that are available in this domain, we would like to call Mr. Kandasamy Umabadi sir to deliver his presentation. Great. Now we need to make some important announcement. If you have any questions during the presentation, please type them in the chat box in your screen. We will bring them up after the presentation and we will have enough time for clarifying all your doubts at the end. Thank you. So over to you, sir.
Thank you so much. Thank you so much, Professor Gopinath. Thanks for your nice introduction and also, the invitation to present. It's a great opportunity. Thank you so much. I will go ahead and get started on cloud computing. So what is cloud computing? So there are three different points that I would like to bring in on cloud computing, right? The first two are the definitions. And the third one is why the term cloud, right? The first definition, or you can call it as a dimension, is we should be able to run the workloads over the internet on a commercial provider's data center. So we introduced three buzzwords here: workload, internet, and commercial providers data center. So what is a workload? So you will hear this term workload throughout cloud computing. So workload is nothing but anything that you do with any of the computational devices. It may be your personal computer or your enterprise computer. It may be your mobile device or laptop or any devices, right? So whatever you do, computation, it may be a big mathematical calculation, or it may be an image processing, text processing, or whatever it is, right? They're all workloads, right? So that's the first buzzword in that definition. The second one is internet. I don't have to explain internet to everyone, so everyone is familiar with what is internet. So I'll go to the third one, the commercial providers data center. So we're not talking about a private data center. We are talking about commercial providers data center. So who are these commercial providers? There are several commercial providers, more than a dozen, I would say, at this point, the big ones. I'm going to talk about the top 3 or 4. The first one who came into this computing model is Amazon. So Amazon has something called Amazon Web Services. That is their service or solution for cloud computing. The next one followed the Amazon is Microsoft. Microsoft came up with Azure. Azure is the Microsoft's cloud. The third one, Google Public Cloud. Google was born on cloud itself, but they came into a commercial model late in the game, but they are the third biggest player in this market. So those are the top three. There are companies like the Oracle, the company that I work for, Oracle Cloud Infrastructure. They're not in the same order, but we are getting into that market, and we are also a player in that market. Of course, Amazon, Microsoft, and Google are the top three big players. So we defined three buzzwords here: workloads, internet, and commercial providers data center. So if you can run a workload, a computational job that you have over the internet on any of these commercial providers data center, then what you're doing is cloud computing. So that's one dimension of defining cloud computing. The next definition: virtualized pool of resources available on demand. Okay, so we have a few buzzwords here: virtualized, resources, on demand. So let's first start with the resources. What are the resources that we are talking about? Compute, that is any calculation you want to do, any processing you want to do, data processing you want to do. They're all compute. Image processing, data processing, scientific calculations, right? They're all compute. Storage. We know what is storage. We all save some data onto our personal devices. It may be your mobile phone or laptop or your personal computer or tablet. Wherever you store, that is the storage. But in cloud, the storage will be somewhere else. So you don't store it locally, you store it somewhere else. So coming to the list of resources: compute, storage, network. We can also get network resources on demand. The same thing for data. We can collect and use the data that's available on the cloud. So data is also a resource. So we started with the compute. Compute is nothing but CPU, memory. Storage is, your file system, right? So these are physical resources. Whereas network, part of the network is physical. You have your switches, cables, right, routers, and things like that. But when it comes to data and applications, it is software. So the data, whatever the format you store them: structured, unstructured. Applications, it can be any applications. It can be vertical applications. It can be industry-specific applications. It can be anything. A small game on our mobile phone to big applications that are used in space exploration by NASA and things like that. It can be anything, as simple as a calculator application on our mobile phone to any level of magnitude. We call all of them applications. So the first buzzword we introduce is resources in this definition. So we know what are all these resources. It can be hardware, it can be software. The next one is on demand. What do you mean by on demand? So for example, I have a computer. I'm using it for myself. If I have a guest at home, if he wants to use the computer and I have a critical job to do, I cannot share my computer with the guest. So that won't scale on demand, right? So that is not going to come into the cloud computing definition. So if I need 2 computers, I should be able to scale up. So that's called on demand. For example, I have 1 terabytes of storage on my laptop. I'm getting some medical data for research. Let's say like it is 2 terabytes. Number 1, I have only 1 terabyte. I can go to an electronic store and buy another terabyte and add it, provided it is feasible to do on that particular model of the laptop or computer. So that's not on demand. If you want 2 terabytes, you will not be able to get it. So that's not cloud computing. So if you need more storage, you should be able to get it on demand. So these are 2 buzzwords: resources, on demand. I was delaying getting into the concept of virtualized pool. This is an involved keyword here, virtualization. A lot of times people get confused with virtualization and cloud computing. Virtualization is making 1 computer look like 2 computers. Make 1 terabyte of storage look like 2 terabyte of storage. Same thing with the network, same thing with the data, right? So you partition them. A single application is shared by multiple users, but they all think like they have a dedicated application for them, right? So that's virtualization. I'll take one resource here and then explain how the virtualization works. We don't have time to go through how the rest of the resources are virtualized. Maybe I can touch a little bit and not in detail. Let's take the compute. You have a physical server. You buy a physical server, right? You can install a software like VMware. You can virtualize and create 4 virtual machines on it. So there is a physical machine, and you can create 4 virtual machines. You can allocate those virtual machines to each of your family member or your friends or students. For example, let's say we buy 5 physical servers. With the 5 physical servers, we can create like 50 virtual machines. We call them VMs, virtual machines. So the actual resources, if you look at, are only 5 physical. But the beauty of the software that we put on, the virtualization software, the famous one is VMware. There are a lot of virtualization softwares. This software layer partitions this 1 compute resource and divides that and then shares among multiple users. So everybody will look like they are owning a server. 50 students in the class, they're all owning the server. They all have 1 server to run a project. Actually, there are only 5 physical servers. We are giving it to 50 people. Now, take that concept, extend that concept to storage, extend that concept to network. There is 1 network, and then you have, let us say, you have some X bandwidth capacity. Then you create the pipes. You can make it 100, 1000, 5000. So everyone can get a dedicated network from one physical network. They are all called virtual networks. The same concept. So since we talked about two physical resources, let us talk about the application. The one good example for this is everyone is using an internet email. It may be a Google Mail, maybe a Yahoo Mail, a Hotmail, or whatever it is. Any internet email, you think that software is out there for you. Actually, there is only one software that runs in Google's cloud. So everyone thinks they have a local version of that, or there is a software out there for you dedicated. So you can imagine tens and thousands or hundred thousands of users are using this application over the internet, but there is only one software that's running. So this is what is called virtualization. It can be a compute virtualization, storage virtualization, network, data applications. So I mentioned that, like, you can take 1 terabyte storage and look like 2 terabyte storage. There is no magic in it. It is the software that does. When you pool them, right? When you pool 1 terabyte from, one region, there is another terabyte from another region, another petabyte coming from another region. You pool all of them together. It all works on a statistical model. People are all not going to use all this storage at the same time. The same thing for compute as well. Not everyone is going to use at the same time. So we leverage that compute resources. So there is a beautiful algorithm that works in between that's managing this. So we talked about the workloads. So since it is a virtualized pool, if user 1 puts more workloads, you can move them onto another virtual resource. Since we have virtualized it, it is completely transparent to them. They are not attached to a physical server. So all these are done by a software that's running the cloud. Okay, so 3 buzzwords here: virtualized pool of resources. Sorry, virtualized pool, resources, and then on demand. So if you can have virtualized pool of resources and then you can provision them on demand, that is what is cloud computing. So that's the second dimension or second definition of cloud computing. So those are the 2 major definitions you will find. There are a lot of other definitions out there. People will, whatever the way they want to do, they will define that. But these are the top 2 that I can find that's more useful for common users like us. Now, in any of these 2 definitions, we haven't used a word called cloud. So why is this term cloud? So they named it as cloud because of 2 reasons. One is global. So the presence of cloud computing model is global. There will be a set of servers in a data center that is in Austin, Austin data center. Let's say like, we have 1,000 servers in that data center. There may be someone sitting in Indonesia using those servers. There will be somebody sitting in India is using those resources. Somebody in Indiana, US, are using those resources. So it is global. In order to scale in terms of performance, we have regions out there. Every region there is a data center. Asia Pacific, EMEA, Europe, Americas, everywhere the data centers will be there. For every provider that we talked about, whether it is Amazon or Microsoft Azure or Google Public Cloud or Oracle Cloud Infrastructure, they all have regions out there. So it's completely transparent how the workload is shifted. It knows when the customer orders, I want 2 CPUs and 40 gig memory for 200 days with 1 terabyte data. If you are making this request from Italy, that will be provisioned in Europe data center or Europe region, right? So the presence of this cloud computing model is global. The physical cloud that we talked about, that is also global. You see cloud everywhere, right? The second reason why they named this as cloud is the nature of the cloud. The physical cloud that we have is amorphous. There are no boundaries. It's a hybrid. So there is no boundary for this cloud. Today, what is the size of the cloud? So AWS can say like, I have 1 million servers, 2 million terabytes of storage, whatnot. But as we speak, that will change, because in cloud, we are going to see the different models of the cloud. One of the model of the cloud is called hybrid cloud, where you can take your hardware, plug it into cloud, a commercial provider's cloud. They call hybrid model. We will talk about that in the later slides. So the size can change, shape can change, right? So tomorrow the cloud adoption is more in Europe, then you will have more resources, more data centers, more regions will be built on the Europe region. If the demand for cloud resources is more in South Africa, the more will be built there. So the size and shape of the cloud is amorphous, much similar to our natural cloud. That is the reason why it's called cloud. Just to summarize, what is cloud computing? We should be able to run our workloads that we run in our data center or in our home computers or the internet in commercial providers' data center. That commercial provider should have virtualized pool of resources, and they should be able to provision them on demand. Okay, so we saw what is cloud computing. Let's go. Why cloud computing? So everything is going fine. We just got on to the internet. Everything is working fine. We started from all monolithic flat file based computing model, and then we came to two-tier model where client server model, and then we came to this internet computing. So everything is now going fine. Why we need to go to cloud computing, right? So people are not going to be, people are continuously improving things, right? Continuous improvement. They're thinking, hey, how do I make things more cost effective, right? So, I mean, academics were working on this, but the people like Amazon, Salesforce.com, some of the pioneers, they thought, hey, we should come up with something innovative that's going to reduce the cost of computing. And also, they were not able to scale with the dedicated hardware. Today, as individuals, we go and buy our computers. Institutions or enterprises, the enterprises may be a telecom company, it may be a university, it may be a hospital system. Everybody is owning a data center. Everybody has an IT department. Everybody has a set of computers. Everybody has terabytes of data, terabytes of storage, multiple applications, custom applications, ready-made applications. So much of data, they all work in silos, meaning each department works as a separate entity. Account receivables will have a system. Account payables will have a system. HR department, human capital management, they will have their own system. The front-end application, CRM, sales and marketing, they will have their own system. Data is all fragmented. They're all running in silos. So you cannot have a unified view of all the data that is out there in the enterprise. So that is the problem that we have in our current solution. The current solution, we call it as on-premise. So if you're running all your computing inside your enterprise, we call them on-premise. So problem with on-premise, you cannot scale. Tomorrow, if you want 2 TV or 2 petabytes, you cannot get it. It's going to take you need to ask for an IT budget that will be increased next year, and then you buy it, deploy it. By then, your need for more storage, more compute will keep going up. So you cannot scale when you do it on-premise, and you don't have coherence. That is the reason why we need to go on to a shared model where we can all put our resources together. We can get some economies of scale. For example, when everybody is using computers in India, people in US are sleeping. Vice versa. You can share resources if it is in a common pool. And also, if you are going to share resources, it has to be coherent. If you have something proprietary, if you don't have a Linux server, you don't have a Windows server, you have something proprietary which you built, that's not going to be easy to share. I mean, it is still possible, it's going to be difficult to share. So the main aspect of cloud computing is sharing that gives two byproducts, which is economies of scale and coherence. If you have one computer and maintain that computer, it's going to be difficult. If you're having 10 computers, then it's worth hiring a person and have a system administrator to administer. If you have 1 terabyte of storage, you don't hire a storage admin to administer 1 terabyte of storage. If you have petabytes of data, you probably need a storage administrator. If you need millions of metadata, there is no way we can even manage that. So we may not need all the storage at the same time. We may do a project. We may want to do a test to test the peak load. We only need it for a few days. You cannot buy that much of storage just for that peak load testing. So when you go to cloud, it is the cloud provider's headache how he manages. He has a huge pool of resources out there, whether it's Amazon Cloud or Microsoft Cloud or Google Cloud or Oracle Cloud, any cloud. They all have data centers around the world. They have thousands and thousands and thousands of servers and storage and network, right? So the sharing is the key for cloud computing. Let's say you are a startup company. You got the funding. You are hiring some 5 employees. Now you have 5 employees. You need to pay them. You need to have a HR system to store their information, right? And then you need to enroll them into benefits. You need to do appraisals for them. You may want to send them for training. You need to manage all of this. Or if you are a manufacturing company, you need to keep an inventory of all your parts. So you need some software, you need some infrastructure. So you'll be spending around 20% of your funding on setting up the infrastructure. When you go to cloud, you only ask for, I need a 5-user worth of compute resources. You have a lot of calculators out there. You can compute you want 2 cores or 4 cores or 5 terabytes or whatever it is. You can compute them. You can buy them. When you buy them, you're not buying them. The concept in cloud is called subscription. So subscription is much similar to our electricity bill that we pay. So electricity or water. That's why there is another name for this, which is not exactly the same, but they synonymously use, called utility computing. It is like utilities that we use and pay on a monthly basis. So that's the reason why you have something like that here, which is called pay as you use. Pay as you use. Let's say there are 100 gallons of water you used. So you pay for 100 gallons. The next month you are going on vacation, you don't use any water, you pay $0, right? So you're not spending any money. So when you buy your resources and put them in your data center, whether you do business or close and go for vacation, you paid for those resources. Your computer is sitting idle, your data center is sitting idle, your network is sitting idle, everything is sitting idle. When you go to the cloud model, you only pay for what you use. So there's no minimal upfront infrastructure cost. So that's what we're talking about, like pay as you use and lower total cost of ownership. To own the infrastructure, you are paying very, very low cost, right? Let's say, like, you did a great product is, going on beta, a lot of customers are interested, you get more funding, you are now hiring 30 employees or 50 employees or 100 employees. What's going to happen to your on-premise data center? Now you need to rent a bigger data center. You need to hire 2 or 3 more system administrators to administer your servers and storage and software, right? So in the cloud model, it will scale automatically. So you're going to pay, since you got the 5-user model, all you need to do is, hey, my employees are now more, I need an 100-user subscription. Doesn't matter. If you use more compute, they're going to send you the bill saying, like, oh, you used more computing. You stored more data into our cloud. So you pay this much, right? So that's the pay as you use, and hence the lower the total cost of ownership. The next one is the quick deployment. So the same example that I gave you, you have a company that is running, right? You have a good product, it's selling well, and everything is, now you want to diversify your product. You are starting another division. So you are asking for whatever you want to ask, like, whether you want only the hardware, like, you want storage, you want servers and network, you can ask for that. It will be instantaneously provisioned to you. Go to any shop, Amazon AWS or Google Cloud or Azure or Oracle. You will get the hardware instantaneously, right? Quick deployment. If we are setting up a data center for our own, even if you take it for your college, it's going to take time. You need to rent a data center, you need to buy servers, storage. Hello?
Okay, no problem. Kanasami, you can continue.
Okay. So it is also manageable. I'll tell you how it is manageable, because we are not managing it. In cloud, it is managed by the cloud. I'm hearing someone is talking, Gopinath.
Okay. I
If you
request
can mute.
participants to mute your microphone, please. It is disturbing the entire show. Please, I request participant, please mute your microphone. Thank you.
Thank you, sir. Okay, sorry. Okay, it's manageable, meaning We are not managing it actually. It is the provider is managing. So people who are in the IT, they know that how difficult it is to manage and keep our IT infrastructure up to date. They will be releasing patches. They'll be releasing new releases. We need to be constantly upgrading our systems, whether it is hardware or software. We'll be constantly getting bug fixes, patches, upgrades. We need to keep updating all of them. In on-premise, there is a downtime involved. The IT department has to coordinate all of these. In cloud, there is a fixed schedule and it is a shared model. There is only one software out there. If they need to patch, they just patch that one instance of the software and everybody gets it. Few days back, Google Mail did an update. A lot of new features. They integrated their Office suite. Everybody got it just like that. Think of running our own email systems. We used to do that 10 years back. Every company will run their own email system. Now, Google Mail is also a corporate mail if you're subscribing a paid subscription. So they are taking care of patching them. They are taking care of installing new releases. If there is a bug, they fix it. We won't even get a patch for that. So that's what we call manageable. The next one is called burst computing. What is burst computing? So we slightly touched on the peak load. So let's say like, I don't know how many of you are familiar with a software called TurboTax. So this is a software that people use in US to pay their taxes. I'm sure there are similar softwares out there in India as well. So in the month of April, there will be a lot of people filing taxes. So the load goes up. So this TurboTax is available in both the models. In the old model, you buy it, they will send you a CD, you install it on your computer and you prepare your tax and then you e-file it. The cloud model, which has been there for more than 10 years, I personally use it. All you need to do is you need a browser. All you need is a browser. You can just do it from your laptop or tablet or your mobile. You can do it from anywhere. You just go in there, log into your account and upload all your documents. And then once you verify, you file the taxes. Now, what happens, people don't file taxes, let's say like, their tax documents come on January timeframe, but your cutoff date is April 15th. People don't file taxes. Some people in January, some people in February, some people in March. They do, some people do it. If you have a tax refund, people who go and do it. If you need to pay taxes, then people defer it all the way to April. You will be surprised. Majority of those filings happen the last week of that second week of April. So what happens? You will have tremendous load coming. Let's say like, the TurboTax is a software that comes from a company called Intuit. Let's say like, Intuit had their own data center. Let's say like they have 100 computers, they put their software on it and everybody goes and files. They'll be bursting. they will not be able to scale. System will fail miserably. So if they are on the cloud, then what happens is cloud is catering for all type of applications. There is a healthcare application, there is an education application, there is a manufacturing application, there is a financial application. There are a few seasonal things. Everybody runs the payroll towards the second, third week of a month. The enrollments, benefits enrollments happen in the end of the year. Performance appraisals. Each company has a different deadline for performance appraisals, right? Year-end processing happens at different times. So cloud is catering for different applications, different workloads. They will not be impacted by everybody trying to file taxes in the week of second week of April. So that's one of the major advantages of cloud computing. When you do that on premise, you will not be able to handle the peak loads. So meeting the unpredictable demand of high computing resources at peak. That's what. So the burst computing is possible in cloud, whereas it is not possible on premise. So those are the major reasons why we should move to cloud. And there are other side benefits you get, like, let me quickly walk through some of these. Like, let's start with this 24/7 support. Yes, because all the cloud vendors, like, you have hundreds and hundreds of customers out there. So they need to provide this 24/7 support. And I heard a couple of days back from Google, like they're talking about 15 minutes response time for these resources. So pay as you go, we saw that total lower total cost of ownership, reliability, because we are not dependent on specific servers, right? It's a huge pool of servers. One server in the pool fails, it doesn't matter. It will automatically relocate to another VM that is available, right? It's highly reliable. We saw that economies of scale, so it's scalability, sustainability. So you can sustain this forever because these are the vendors. Their main job is to provide these resources. They will keep on upgrading, updating, patching. They will be sustaining it for a longer period of time than the individual enterprises. Security, we will talk about security on one of the slides. Security is more, think of this. If you are living in an apartment versus if you are living in your own single family house, you need to install all security devices. You need to install a security camera, and then you need to put like motion sensors, and then you need to connect this to a security company, like, that alerts the police department and all that stuff. You need to invest all of them on your own. Whereas you live in an apartment, they all pool resources, they put a dedicated security, and they put security cameras, they monitor it, they tie up. The cost that you pay for security is less. And sometimes you may not maintain it. You may install it in the beginning, you may not maintain it. You're not checking every day the security camera is working in your house. You live in an apartment and you're sharing this security system. There are dedicated people. They have a routine to check the cameras are working, motion sensors are working, communication is going out to the monitoring people, and then the alerts are going to the police department. They periodically run the drills, and then they make sure things are working. So it is more secure on the cloud than on premise. Lower capital expenditure. We are not paying upfront. We are not investing if you're starting a company, you're a manufacturing plant, you're not investing on the IT department at all. You don't need any of those. because you don't know, you only have 5 people on the day one or 3 people working for you in a startup. So you don't have to invest so much for the IT. All you need to do is one of those vendors, you go there, I have a 3 people employee, I need payroll, I need the HR system, I need, if it's a manufacturing company, I want to have an inventory system and whatnot. So you only ask for what you need and for 3 users, and then you buy it, you don't pay anything. Unless you use it. Only if you use, you will pay. So lower capital expenditure frees up internal resources. You don't need a lot of DBAs. You don't need a lot of system administrators. You don't need a lot of storage administrators. You don't need a lot of network administrators, right? So frees up a lot of internal resources, highly automated. Think of, for your company, you may be having 10 databases, maybe 10 application systems, right? 20 servers, 1 petabyte of data. But think of Google Cloud or Amazon AWS. They have thousands and thousands of servers, thousands and thousands of applications, thousands and thousands of storage. How they do the deployment for all of them? How they do the deployment? How will they do the maintenance? How will they do fault detection and correction? They need to automate it. So they invest heavily on automation. When they push a button, the security fix for a database or operating system goes on to millions and millions of pods, they call pods, or VMs, right? So how can we do that? You cannot hire thousands and thousands of DBAs to do that. You cannot hire thousands and thousands of system administrators to do that. It's all done automatically, highly automated. And easy, agile deployment. So we talked about how easy to deploy, meaning we are not even deploying it. We are just asking, okay, give it to me. Like instead of buying a cloth, shopping around, taking it to a tailor who can cut and stitch and then give it to your size. You go there, you know what your size is, you pick up a shirt. How easy it is, right? In the cloud, the pods are, there are different sizes of the pods. Like, you have small, medium, large, and a lot of sizes out there. It's exactly like your t-shirt sizes. You can buy it, you can scale. Let's say, like, tomorrow your company grows and, you hit a jackpot and then now you are $1 million company or a $1 billion company. Doesn't matter. One student gets one server, few storage, and start working on a college project, he can do it. You can take a university like Stanford can go in there and do a human genome project that involves petabytes of data. You can do that also, right? So that's the agility we have, and easy to deploy, and it's all taken care by these providers. So if you are still not convinced on why we should go to cloud computing, look at the numbers. So cloud computing itself is not new. I won't even go to 2005. In 1960s is what they say. Like, there were a lot of models called time sharing. Different models were developed for different projects. So sharing has been always there on the scientist agenda for different purposes, not on the computing side. So that was there in 60s. But on the computing world, cloud computing slowly started around 2005. We are all, I don't know how many of you are using internet email. We had been using internet email from around that time onwards. but commercially did not pick up until 2010 or so. So it's already a decade-old technology. I mean, it's more than decade-old, but commercially started, used by enterprises around 2010 timeframe. So you see 3 different graphs here, and we will talk about those 3 different models of cloud computing in the next slide. So you need to sum up all those revenue dollars, and then Gartner did the research, and they said like 2020 it is 266 billion dollar revenue. In 2020 it is a 266 billion dollar. 2021 we have 300. 2022 354. So that big of the market is out there. On the right side, what you see is only the SaaS revenue, right? On the left side, you see all SaaS, infrastructure as service and platform as service, and there are a lot of service models. So if you add all of them, it will be like, it will be crossing more than $1,000 billion.
Sorry to interrupt, Kandaswamy. Can you just expand this SaaS, PaaS, and other one?
Yeah. Okay, it's here. I'm going to come to that. SaaS, PaaS, IaaS, right? So we need to wait for one more slide so we can get there.
Thank you.
Yeah. So before we go in there, right? So one more dimension to the cloud computing models, and then we will go to what is SaaS, PaaS, and IaaS. So the cloud can be 4 different major models, right? One is the private cloud. Private cloud is much similar to what we have today on-premise. The on-premise itself can be converted into a private cloud. So let me read this out. Hosting all your computing infrastructure yourself and is not shared. So what is the benefit? You're not sharing with anyone. The security and control, I'm not sure about the security because you need to put all the security that all these big cloud providers are providing, but you have full control over it. If you want to shut it down, you can shut it down, and whatever you want to do, it's all yours, and it's there in your campus, and you do it. So it's on a private network, right? A lot of people think that is more secure, right? So what we can do is your existing infrastructure, let's say like your university has 1,000 servers, 1 petabyte of data, and then you have a good network. So you may have different departments. May have different departments in terms of faculty, like you have civil engineering, mechanical engineering, computer science, and things like that. And job-based, you also have a sales department, and then you have admin department. You have faculty, right? So you will have different systems, different softwares, right? So the admin department may be using a HR software, and then sales department may be using a CRM software. Now you can pool all these resources and mimic like a cloud, but you're not sharing with another university. You're not sharing it with another hospital system. You're not sharing with anybody. It is a dedicated cloud for yourself. Your servers, your storage, your network, your administrators are administrating it, That's your own cloud. But if we keep, so you still have some benefit to this. You still have some benefit to this because you are sharing within your university. Take a big hospital system, right? They may have multiple branches of that hospital. The hospital have different departments: pediatrics, general medicine, cancer treatment. So they may have a different departments. They may have different systems. They may have different hardware resources. They may have different software resources. They may have different personnel. So you bring all of them together and create a private cloud for Apollo hospitals. Create a private cloud for your university, right? So that's what is the private cloud. Now, private cloud and community cloud are almost similar. Let's say like all the university people come together and they say, let's share our resources. We're all doing similar job. Let's share our resources, especially on the faculty side and student side. Probably they may not be comfortable sharing the admin side of it. So you get all the course content, you get all your student project work, all the collaboration happens. It can be a education cloud for India. All the hospitals come together, they create a community cloud for a specific country, for a specific specialty, right? Gynecology cloud, right? All the hospital departments, gynecology departments come together, they create a cloud. They can collaborate, right? That's community cloud. Now, there is a public cloud. All the definition that I gave in my first slide is about the public cloud. The Google Cloud, Amazon Cloud, Microsoft Cloud, Oracle Cloud, all these clouds are public clouds. If you put your software, if you put your hardware on any of those providers' data centers, it is public. It's public cloud. It's highly shared. You have scale of economy, which is very great, right? That's the, if you want a cheaper solution, public cloud is the best solution. Now, there is a problem. Everybody has data center now. Everybody is using their own applications. They're using their own network, their own data center, everything. One fine morning, everybody says, okay, cloud computing model is the best model, let's go to the cloud. Now the question comes, what do I do with all the servers that I have in my data center? What do I do with all the people who are working? What do I do with all the data that I have? Okay, you can migrate, you can put a 10-year migration plan, and you can migrate all your on-premise hardware and software to cloud. Now, some people will say, yeah, I can put my education system on public cloud. That's not a big deal. But I cannot put my customer relationship data, CRM data, on the cloud. If people know who are all my customers and their contact details and things like that, people will start calling them and start selling to them. So that's a very, very protected data. I may not put it there. So I may not put the CRM out there, but I'm okay to put the education part of it. I'm okay to put HR part of it. I can run, probably I will not run the payroll, but I can put benefit system on it. So what they will do is they keep some of the key systems on premise, and put some of them which doesn't require a lot of security onto the public cloud. So it's a mix of private and public cloud. It can be a mix of community and public cloud too. So if we have any of those mix, it's called a hybrid cloud. So people will get used to it slowly. Then they will think, okay, it's all secure. Now I can also move my financial applications onto cloud, right? So they eventually go into public model, but they may not do it on the day one. Day one, what are you going to do? You're going to get rid of all your DBAs. You're going to fire all your DBAs. You're going to fire all your system administrators. You cannot do that. What do you do with all the hardware that you bought, right? So you go in a phased approach to public cloud. So when you keep some of them on premise, some of them in public, that's what it's called hybrid. But there are subcategories of that where you can still keep all your hardware and then put the cloud software on it. So there are multiple varieties. That's why the cloud itself, we said amorphous. It's loosely defined, no boundaries, right? So the hybrid is a very, very loose term. Any of these mix can be called hybrid. So we will keep our hardware. Let's use the cloud software, but that will be running in our data center. But they will be patching and managing it per license. Sorry, not license, it's called subscription. In the old model, we call license. In the cloud model, we call subscription. Okay. Now, the question that Professor Gopinath asked, what are the other models? So the model that we saw earlier, based on where the computing happens, whether it is public or private or community or mixed hybrid model. This is what is being provided. This is service, cloud service model. That's another keyword or buzzword we will use often in this, called cloud service. So it's all called services. Anything you do is service, right? So the bottommost on the left side, you see IaaS, sorry, right? Infrastructure as service. I don't know what's happening. Okay, infrastructure as service. So what are the infrastructure items that we saw, right? We talked about resources. If you take server, storage, network, right, and provision them to the customers, that's what is called infrastructure as service. Okay, who will use it? IT departments. What they'll do, hey, I don't want to maintain a data center. I don't want to buy any servers. I don't want to buy any storage. I don't want to buy any network. I want to buy everything from a provider. I go to Amazon, buy 10 servers and 100 terabytes of data storage, and then get some network, right? So you can get these things. It's like a different shops, like, you go, right? You go and buy this from that shop, and you buy software from another shop and things like that. So IaaS, so a provider is an IaaS provider. They provide server, storage, network, and they call. You can also individually call them as server as a service, storage as a service, network as a service. So we are putting all of them together and calling it as infrastructure as service. So that is on the hardware side. So IT people, IT department primarily uses the infrastructure as service. Now comes So they only get the hardware, everything they do on their own. All the software stack and everything, they buy the hardware on Google or Amazon, and then we do all our software work there. We are not giving that to anybody. We are going to keep that with us. So that's when you go IaaS. Now, you also want an operating system put on that hardware. And you want application stack. So application stack can be like this. You're writing a web application. You need to run the web application on a web server. So you write a web application, but you need a web server to deploy. You need an application server to deploy. So for application server and web server to run, you need an operating system that needs to sit on the server. So the shop where you go and buy these things, operating system, application stack, is platform as a service. You can also call operating system as a service or application as a service. You can call anything as a service. So there are not only in computing, the service model is coming up in almost all industries. Your Uber and Ola is car as a service, right? So you have a lot of things are coming up, like your vacation homes. It's a home as a service, right? So anything can be service, right? So, but we are putting up all these things as a platform umbrella. Here is where people will go and develop an application. Of course, operating system and application stack sits on server storage network. So a PaaS vendor has to provide all of this. Who will buy it? Who will use it? The application developers. If a student wants to run a project, if he gets only these things like server storage network, that's not enough. He also needs an operating system to be running there. On top of that, an application or web server running. Then he can write his Java, Python, whatever it is, and they can put it on, deploy it on those. Right? So that's platform as service. Now, why have I'm a CTO of a company. I don't want to go through all this headache. I don't want to build an application. People are already building applications, and there are many vendors. They're giving these applications. You want HR applications? There are plenty of vendors. There are financial applications. There are plenty of vendors. If you need vertical applications like industry specific, telecom applications, billing applications, and healthcare applications, plenty of applications are there. It's called packaged software. I just go and buy it. I started a company. I want HR applications for 10 employee subscription. Okay, my product is a manufacturing product. So I'll buy. I have 3 people in my manufacturing unit. So they'll be operating it. So I'll buy manufacturing application for 3 users. The beauty of this model is you can buy it for 3 people. And if nobody is using it, your factory hasn't started yet, you pay $0. You started it, you get a lot of demand, you're producing more, you hire a few more people, they log in, 5 people, next month bill automatically you'll get it for 5 people. Pay as you use. So no headache. You can just buy hardware. You can buy hardware plus some platform. You can also buy the entire suite of things that is SaaS that's sitting on top. On the right hand side, how this is defined is based on who manages it. So in on-premise, today's model. If you haven't gone to cloud yet, that's called on-premise. In the on-premise model, we manage everything. We manage the network, we manage storage. If you're in a university, you go in there and you talk to your IT department. Now they will be having network administrator, they're managing network, storage, server, virtualization, VMs, operating systems, Windows, Linux, middleware, WebLogic server, runtime. Runtime is something where you run your production systems and data and then applications, multiple applications. All of these needs to be maintained. You need people, network engineers, you have storage engineers, server administrators, you have OS administrators, and then you need application administrators. So all of these you need to manage on your own, on-premise. If you are taking infrastructure as a service, right? So the bottom 4 are managed by the cloud provider. The rest of them you manage. Platform as service, majority of them they manage, but you build the applications, deploy, you own the data, you own the applications. Nobody is managing. You need to patch, you need to do whatever you want for your application. But for the rest of it, your mid-tier, your operating system, your server, storage, network, everything will be managed by your cloud provider. In software as service, you don't have to do anything. All you need to tell is, I'm buying for 5 user subscription. I want this, like how you do the shopping, right? In your shopping cart, you say like, I want HR application, I want payroll application, I want, a sales application, I want some data analysis, data analytics. You buy all of them, subscribe it. You will get your subscription bill at the end of the month based on how much you used, how much storage you used, how much compute you used, how much of their software you used. Based on that, they will be sending you a bill. Next month, your company grows, more people, more bill. You're not doing business, COVID-19 shut down for 3 months, you pay no bill. That's the beauty of software as service. Okay, I'm going to go a little fast now because I think we are running out of time. Security. There is one thing people threaten you with the security. We kind of touched it a little bit. So here's the a key takeaway on the security. Yes, everybody will be afraid. Hey, I had my own data center. I had everything running here. I can see the physical server. There is a data center. My administrators are working there. Everything is under my control. I feel more secure. Now, I'm putting everything onto the cloud. I don't see any servers in our data center. I don't see any people. There are only 1 or 2 people maintaining our bare minimum infrastructure. I used to have 100 people in the IT department. Now I only have 4 people sitting there. So I'm a little concerned because they're saying everything is running in Google, everything is running in Amazon, everything is running on Oracle. I will feel nervous because they are not running in my campus, right? But that's a false sense of security that we have. They are the professionals, the cloud providers. They screen constantly. They keep up and gather data about the firewalls, any intrusions coming, and any intrusion comes, provide the counteractive action, all that stuff they have. Even inside there, so anything that comes from outside, they scan. Anything from inside, they look at all the information stream. So 2 people may be like, there is a college 1 and college 2. They both are getting resources from the same cloud, Amazon cloud. but they will make sure the information is not going from one client to another client, right? So the recent history of public cloud has demonstrated that brand name multi-tenant public cloud services are highly resistant to attack. In fact, provide a more secure starting point than most traditional in-house implementations. This is the example that I gave, like, the security system in your house versus when you live in a luxury apartment complex. So cloud providers have more incentive, right, to put more security. For example, one security breach in cloud in Amazon cloud will bring Amazon stock crumbling down. But if something happens to our security camera at home, nobody cares. If something happens to the security system in our data center in our college, not a big deal. There is no the market crash happening. So they have more incentive to deploy latest and greatest security on the cloud. So they hire experienced system and vulnerability managers. They constantly look at, see, this is not you're hiring for one application, thousands and thousands of applications. They can afford to hire top security experts, economies of scale. One application, you hire a top security expert, you will not be able to pay for them. They can pay because they are hosting thousands and thousands and thousands of applications. Okay, so the key takeaway on the security, so don't be scared. Organizations should neither underestimate cloud risks. So there is a risk. Don't underestimate it because it's out there. Whether it is in a public cloud or private cloud, there is a risk. Okay, and take cloud security for granted, nor overestimate cloud risks and allow unwarranted fears about the security to inhibit their use of public cloud services. Don't be too scared and then say, oh, I will not go to the public cloud. I'll be in our private cloud. You're going to be paying a lot. You're going to be putting a lot of resources out there. You go on a summer vacation, college closes down. What happens to all your resources? They're all sitting idle. You're not sharing. And burst computing. You want to run a major project, a research project. You want to run petabytes of data and simulate and test it. That's for a college project for 10 days. Where will you get the resources? If you are not in cloud, if you're not sharing resources across, that's not possible. So cloud security, we need to be cautious. The Gartner predicts that through 2020, 90% of the cloud security failures will be the customer's fault. That means all the security features are out there. When you buy a subscription for a hardware or a software, it will be asking you a lot of questions. Hey, do you need encryption? Do you need a data vault? Do you need a HTTPS secure protocol? It will be asking you a lot of questions, and then it will be adding a few cents for here and there. Then, oh, if I add that, like it's going to charge me 2 cents more per user, then okay, I'll not take it. If we compromise on security, they will not care. They will say like, okay, you don't want to put that security, that's fine. I'll charge you less. So it is completely up to the consumer to decide what security we want to put it on when we go to the cloud. it will be the customer's fault. 95% of fault will be customer's fault because they're not subscribing to the security features out there. Okay, so the key takeaway is don't underestimate the security risk. At the same time, don't overestimate and then stop moving to cloud. Okay, I think it's 10:30. How much time I have, Professor?
How many slides you have, Mr. Kanasamy? You can take 10 minutes.
Okay. I may have to cut down a few things, but I will try to take two use cases and then see how cloud benefits in these two cases.
Yes, yes,
right?
yes.
So the first one on education. So education. So you have in an educational system, we have students, we have faculty, we have admin, and then we have classes that are happening, and then there is an admission process, and then there is a class preparation and the review that's done by the faculty at home or wherever, right? The examination system. So we have all of these entities out there, right? So each entity will gain something when they go to cloud. Let's see one by one. Eliminates the need for expensive and outdated textbooks, right? That's already happening. So it's very expensive, right? So the two problems there, one is expensive, the other one is outdated. When you have these materials digital, and right away you get some benefits when you go digital, right? So ebook is always cheaper than the paper book, right? And the textbooks will be outdated because you have a turnaround time in printing them and distributing them. So when you have these materials on cloud, you can always update. There is one update you do to the digital material on the cloud that will be available to all the people who downloads it from that point. It can even send notifications for people saying, like, all the people who have subscribed to that text, it's going to say, hey, your textbook has been updated. Do you want to refresh? Right? So, and it eliminates the need and cost of expensive hardware. So this is something similar to the general thing that we were talking about. You don't have to hardware in your university. Offers easy accessibility and mobility. You can access it through your computer at the university, or you can go home. If you have a personal computer, you can access it. You can access it through a mobile phone. You can access it through your laptop or tablet or whatever. And the mobility, like, you carry this wherever you go. You can be in a train, you can be in a plane, you can be anywhere, and you can access this course material. Not only the course material, for the faculty, they can do their work online. Evaluations can be done online, right? So offers more collaboration. So this is for higher education. For higher education, you may want to collaborate. There may be some bigger projects. I know there are some projects that government gives, like, hey, if you can find the solution for this problem, I'm throwing out this as a challenge, and there will be 10 colleges, 20 colleges picked up for that. They all need to collaborate. Think of a scenario where we don't have cloud. How are they going to collaborate? That collaboration is going to be much, much easier. You link some of the systems with those universities, and then you create a community cloud, right? Let's say, like, hey, we don't have a supercomputing capability in India. You need to develop. This is what 20 years back, one of the central government did, and 3 universities were identified to work on the supercomputing project. I know they were exchanging things through mails and physically running around and all that stuff, but having meetings and collaborations and things like that. Look at the cloud. They all work on the same server. They all get the same view of the data. They can collaborate well. Not only that, in addition to that, like, you also get all the collaboration tools like the Google Meet, Zoom, right? It's all on the cloud. Google Meet is, so we are on cloud right now. This presentation is happening on cloud, right? So eliminates costs associated with the paper cutting. Of course, it is the CO2 cut down, and we will have greener schools and colleges. Okay, I will skip the use cases that we have. The Carnegie Mellon University in US, they had a project on building management, and they were all doing discreetly. Each department was doing their work independently. They moved to Microsoft Azure and BI Cloud. Their energy consumption came down by 30%. And there is a university in India, Sharda University in Delhi. They do a lot of work, community projects, and they were not able to keep track of all these community projects. They went on to the Oracle Cloud Infrastructure, which is the Oracle Cloud, and they were able to track those projects, and then they were able to cut down the cost by 20 to 25%. So takeaways for education. So it's high time that, like, we need to include cloud computing to every university curriculum. There are a lot of grants out there on the cloud. If students want to do projects, both Microsoft and Google, they have grants out there. If you're doing an academic project on certain, energy efficiency related or poverty related and things like that, for those projects, the cloud resources, compute, storage, the whole stack, including the software, will be free for that project period. So please leverage, do some research. If you need some information, and get in touch with me, I'll be able to direct you to the right people. So simulation of networks on cloud. If you are doing some projects like you want to simulate a network, how do you do? We can only do that in mathematical models, and we cannot buy such a huge hardware and simulate. You can go on to any of the public clouds, Azure, and then you can rent storage, compute, and network, and then simulate the network topology that you had come up with, and then test it out. So let me jump to the last point, the preemptive pricing model. So you don't have to buy all of these with the full cost. And if you are going to run your project for 50 minutes simulation, you'll be charged only for 50 minutes. And then the preemptive pricing model is the model where you can say, mine is not a critical project. This is not a mission critical project. This is an academic project. I can run it anytime. I can run it in the night. I can run it on the weekend. I can run it. And if you have a cloud bursting happening, if you need more resources for other projects, you can take away my resources. If you agree to the term, your price is 80% less. This will be very useful for the students. You should explore these options. You go to a vendor who bills by minute. go to a vendor who offers preemptive pricing model that is 80% less than the regular pricing. So if you want to simulate network topologies, simulating robots doing the work across multiple campuses, how do you do that? Without a cloud, you can't even imagine how you can do that. So, I mean, you can still do it in the internet model, but it is going to be very, very, very expensive. Okay, I think we are running out of time. Okay, this one I skipped this. Basically, what I wanted to say is, you know, how we talked about in healthcare, sorry, the education, healthcare also we can leverage, and there are good points out there, but I'm running out of time. I want to spend more time on a Q&A. But there is one important aspect of healthcare that I want to talk about, the first one. So 76% of organizations would like to or already participating in precision medicine. I throw in here a buzzword called precision medicine. The medicine that we practice today is not precision medicine. So it's a one size fit all. If you are diabetic, there is one medicine. All the diabetics will take that medicine. Maybe there are 2-3 variations to that, like, you know, if you are older, you take this, if you are younger, you take this much, kind of thing. But there is no different medication for different people, right? The same thing. So one person's lung disease is not same as other person's lung disease, but the medicine that is prescribed is same, because we cannot customize these medications, we cannot test them in that model. So 76% of the organizations are going into the precision medicine. Actually, but I'm not promoting Siddha medicine. Siddha used to be a precision medicine. They don't give the same medicine for everybody. They will look at you, they'll check what type of body you have, right? And based on that, they will prescribe. They hand make the medicine. They grind it on the spot. I mean, I'm not talking about the current Siddha, commercial Siddha. I'm talking about the traditional Siddha. This is what they do. Precision medicine. So how is this precision medicine and cloud are related? Right? If you want to have precision medicine, you need to do the clinical trials, which are hundreds and thousands and 10,000 times of clinical trials that you need to do, because the permutation combination that you may come up is huge. You need to kill that many rats and monkeys before you can even come to the clinical trial one. So that's where the cloud computing comes into. So you can go to any of these cloud, like Google Cloud. It's called Google Genomics Cloud, right? So Stanford Medicine did a project on this, right? So what they did was they have genomics data in the cloud. It's available for all of us for free. So what is genomics? Genomics project is where the human genetic information is all digitized. It is available. It's a 13 years project, and it was done. It is available. What is the size of this data? The size of this data is like 35 petabytes. It's in 2018. Anyone wants to do, if you're a biology student, if you are doing a research in a biological science, you cannot even buy that much hardware to put that genomic data and then do your research, right? So you can go to the Google Cloud. You just buy one virtual machine to store your results. Maybe you take like few gigabytes of data storage, right? And then you bring in whatever data that you want to run it against, genomic data, and then find out. Let's say you come up with a cohort of patient data, or you have a patient, 36-year-old smoker who is hit with the colon cancer, stage 3. Now you want to see what kind of genetic composition is matching to this person's genetics. All you need to do, you can find a non-peak hour for a low price on a Sunday, right? You can also choose a preemptive model, take your data. So one individual's genomic data itself is going to be gigabytes. You take your data, upload to the Google Cloud, and then run the query against the genomics. Within few minutes, you will be able to find the cohort of people who can who are matched with this genetic data. That's almost impossible for a person to do that either at home or in their laboratory or in their medical university. It's impossible to do it. It's not one student we are talking about. It is like multiple people can go and do the same project or multiple projects simultaneously. Google will scale, right? Once the cohort is identified, okay, here are the 100 people who match with this. They are into these clinical trial medicines. You can also try that. Then the person who did the research, they can contact those 100 people and they can start gathering more data on that. So that's the beauty of cloud. So it's not only the hardware resources. This is an example where even the data is available as a cloud. So human genomics data is available as a cloud service. Okay, with that, I will start the Q&A. So the picture I have here is the Mark Benef, who is the CEO of Salesforce.com. He said there are cloud services for companies of all sizes. You may be a student, you have a small project, or you are NASA, you have a big space project. The cloud can cater to everyone. That's why cloud is for everyone, and cloud is a democracy. It doesn't discriminate people. People sitting anywhere in the globe can access human genomic data with no cost, and you pay only when you do your research. And if your research project is one of the non-profit project, then that is also free. That's all I have for today. And if there are any questions, I'll take. Gopinath,
Yes.
can you shoot the questions, please?
Thank you very much for your presentation, Swami. And I'll take care of. We have some few questions. Just I'll read out. Sir, when I have some beta byte of data, if I switch between different cloud service provider, how I will transfer the data between two different cloud providers?
Yeah. So you can first of all, I don't know why you need to split between two providers. Number one, right? So even if you want to split between two providers, you can do that. And a lot of cloud vendors are coming up with a partnership. For example, the guy I'm showing on the picture here, Mark Benef, right, Salesforce, they have tie-up with almost all vendors. They have tie-up with Microsoft, they have tie-up with Oracle, they have tie-up with Amazon. They all have pipes, they have agreements, they all work together. They provide that same speed and then interoperability. It is doable. But I wouldn't recommend venturing on multi-cloud unless you have a service that is only available with this vendor. There is another service that is only available with another vendor. Then you go the hybrid, not hybrid. It's called multi-cloud, right? So you go multi-cloud only if these features are not possible. But most of the vendors are self-contained. And for example, I can't see a project that you cannot do only in Amazon cloud or only in Azure cloud. So nowadays it's like, one-stop shop, right? Like, you go there, they give SaaS, they give PaaS, they give IaaS, they give data analytics. They provide everything, right? If you choose the right vendor, there is no need for you to go for multi-cloud. But even if you want to go for multi-cloud, these big vendors, they already have tie-up. They have very high bandwidth pipes between their own clouds. Did that answer the question?
I think so. Can another question? How hybrid cloud differ from Arc network? How hybrid cloud differ from Arc network?
Not sure what is Arc network is, but I will tell you, right? If Arc network keeps something on premise, it allows you to do something on premise, something on the internet, then Arc network is also hybrid. Hybrid is a what do you call a phenomena, right? Like, it's a model, right? I don't know what Arc does, so I cannot give the comparison. But if Arc supports, run something on premise in your data center, run something on the provider's data center, then Arc is also an hybrid. But I don't know what is Arc network.
Thank you, Mr. Kalsami. And another question, how is Open Compute project related to cloud computing?
I think Open Compute is also a cloud computing. The only difference is it is open source. That means you don't put commercial ones, and you provide the platforms. People bring in their own infrastructure, and they are connected and shared, and then you do the computing. So that's what I think is Open Compute.
Yes, I think limited. Okay, another question, Mr. Kandasamy. AWS service is free for only 1 year. Any other free servers existing in India or in the world?
Yeah, it depends on the project that you are working on, right? It depends on the project. Google gives a lot of free services. I don't know what application you are trying to do. So a lot of I don't know, you are a faculty or a student. For students, a lot of resources are free. So, and if you choose a project which is a non-profit, that is completely free on Google.
Okay, thank you, Kandasamy. Another question, sir. Only 3 big players, Amazon, Microsoft, Google, have a monopoly over cloud market. Is it good in long run?
Yeah, so it is not good, but That's not true. There are only 3 top players, but there are other players like IBM is out there, and there is HP, there is Oracle, and the advantage that the first player has. First player is very top. The gap is very high. The first player is the Amazon. So Amazon came up with this model 15 years back. Obviously, they're going to have the advantage, right? So when people were thinking cloud is not the right way to go, right? Will cloud will be secure, right? Will cloud scale for big enterprises? People had a lot of doubts about how the cloud is going to pan out. So definitely Amazon took the challenge. They went on first. Obviously, they have the lead. Microsoft immediately realized, hey, this is the direction going forward, so we also should get on. 5 years later, they got on. And then Google was born on cloud. They didn't realize what they were offering is cloud. So Google Search is cloud, and Google Mail is cloud. So many things. Google Docs is cloud, right? Google Meet is cloud. So they didn't realize what all the services that they were offering were cloud, but their pricing model was different. They were giving out everything for free, and then they were getting their revenue on the ad. But they are into the commercial cloud model now, and there are a lot of other players coming up. Obviously, monopoly is not good, but this is not a monopoly like where we had Windows operating system that was monopolizing the complete desktop. So monopoly is going to be there. Whoever comes first, they take the big market share. Everybody else has to run behind them. That's why the leaders always, get the big piece of the pie.
Thank you, Mr. Kanasamy. I think we have completed the question and answer. I think no more questions. Mr. Rajan.
Yes, sir. So thank you very much, sir, for your valuable information regarding the emerging cloud computing services and the available job prospects in cloud computing domain. The overall industrial scenario that you have explained will definitely help many of our student participants for achieving the rewarding career in future. Now, I would like to request our Dr. C. Sendamari Kannan, Assistant Professor, Department of Mechanical Engineering, for giving more opportunity.
Sir, good morning, sir. I am audible, sir.
Yes,
sir, you are audible, sir.
Yes.
Thank you, sir. Thank you, sir. So, first of all, I would like to thank the today's speaker, Sri Kandaswamy Umapati, Senior Director, HCM Cloud Operations, Oracle USA Inc., Redwood Shores CA, for sharing his valuable thoughts and giving an excellent presentation in such a way that any person, even our mechanical engineers, can able to understand the term cloud computing very clearly, sir. Thank you very much, sir, for giving us such a wonderful session. Also, I thank sir for readily accepting our invitation to deliver such a wonderful talk in this pandemic situation. Thank you very much, sir. I hope the gathered knowledge and information from this webinar will be definitely helpful to us to motivate and drive us toward this area of study. Also, I want to thank our beloved principal, Dr. S. Ganesh Vaidyanathan, for his continuous support in conducting his workshop. We express our deep gratitude to the SVC management. I thank the participants without whom this webinar would not be a success. I thank the coordinators, Dr. S. Gopinath, Dr. C. Sendamari Kannan, Mr. Sendil Rajan, Mr. N. Satish, for making this workshop a memorable one. On behalf of the organizing team, we extend our special thanks to Mr. A. Kumarasamy for helping us in streaming this webinar in YouTube. Once again, I thank everyone for their extended support and cooperation in making this webinar a grand success. Thank you, sir. Thank you very much, sir.
Thank you very much. Appreciate everyone for dialing in, and hope this helps you. Thank you.
Thank you very much for your excellent presentation. Even you nicely started with the simple way, and even as Sendamari Kannan told, that even a small newcomers, those who doesn't know about cloud computing might be getting a lot of information from you. Really, and I think we may come to you for some. You gave some tips to know that utilizing some common resources for education purpose. That also we plan. I'll come out with some proposal. Kindly help us to get some resources to utilize.
Sure,
Yes,
sure, we will do.
yes,
Sure,
Kansara,
we'll do that. Thank you so much.
Thank you, sir. Thank you very much.
Thank you.
Thanks for a valuable time. Thanks for a valuable time for sparing with us. Thanks a lot.
Thank you. Thank you so
Once
much.
again, thank you, sir, for being with us today, despite your busy schedule. Now the feedback link is posted in the chat box, and the same will be active for just 30 minutes. Hence, I request all our participants to quickly submit their feedback by accessing the link for receiving the e-certificate. After 30 minutes, the link will be deactivated and will not accept any more responses. Great. Once again, thank you, everyone. We appreciate you for joining us today, and we will see you in the next event. Thank you all.
Thank you, Gopi sir.
Thank you.
Okay.
Sir, thank you, sir. Thank you very much, sir, for being with us for this 2 hours.
Yes, sir. Informative. In simple way, sir communicated the content.
Yes.
Nice. Thank you. Thank you all.
I think you got some case study also in the supply chain. Time is totally the constraint for us actually.
Gopinath sir, thank you sir.
So, Mr. Kumarasamy sir, you can turn off the live streaming, sir.